In this video, we will discuss about subtopic 5.4, which is about phase diagram. At the end of this lesson, students should be able to define phase, triple point, and critical point. And the other one is, students should be able to identify triple point and critical point on the phase diagram. Phase. Okay, what is meant by phase? So phase is a state of matter that is uniform throughout in a chemical composition and physical state. Phase of a system are part of it which are separated by a distinct boundary such as solid, liquid, and gas. So remember that three phases exist in the system, okay, which is number one is solid phase, number two liquid phase, and number three is gas phase. Gas also known as vapor. Phase diagram. Phase diagram is a graphical plot of pressure versus temperature that shows the condition at which substance exists as solid, liquid, or gas. Okay, so look at to this phase diagram. Axis Y is pressure and axis X is temperature. Region. Region is a space between the line that correspond to the stable phase, either solid, liquid, or gas of a component. Each region correspond to one phase. Okay, so look at to this phase diagram. First region is the space between BO line and CO line. This is the first region. This region corresponds to solid phase. And second region is the space between CO and OA line. Okay, this is the second region. This region corresponds to only for liquid phase. And the third region is the space between BO and OA line. Okay, this region only correspond to gas phase. Okay, phase boundaries. Okay, what is mean by phase boundaries? Okay, before that, you must know that phase boundary also can be called as equilibrium curve. Okay, phase boundary is a line that separating region that correspond to the temperature and pressure under which two phases are in equilibrium. Okay, so look at to this phase diagram. Okay, so we have three phase boundaries. Okay, which is number one, phase boundaries line OB. Okay, these boundaries between solid and gas phase. So any point lie on the line OB, the system exists in the two phase, which is solid and gas in equilibrium. Okay, second phase boundaries, which is line OC. Okay, line OC is the boundaries between solid and liquid phase. So any point lie on the line OC, the system exists in two phase in equilibrium, which is between phase solid and liquid in equilibrium. Okay, the last one is line OA. This is a third phase boundary, which is the boundaries between liquid and gas phase. So any point lie on the line OA, the system exists in two phase in equilibrium, which is between phase liquid and gas phase in equilibrium. Triple point. What is the definition of the triple point? Okay, so triple point is the point at which three lines are joined that correspond to the temperature and pressure, which is three phase simultaneously exist in equilibrium. Okay, so this point is the triple point. Okay, because this point, at this point, join three lines, because the first line is the boundaries between solid and gas. Okay, the second line is the boundaries between solid, liquid, and the third line is the boundaries between liquid and vapor. So at this point, three phase exist in equilibrium, which is phase solid, liquid, and gas or vapor. Critical point. How about critical point? Okay, what is meant by critical point? So critical point is the point on the liquid gas equilibrium curve, which is above it is impossible to condense a gas into a liquid. At this point, average kinetic energy of molecule is so high that the vapor cannot be condensed no matter how much pressure is applied. Okay, at this point, density of liquid equal to the density of gas. And the phase boundary disappear at this critical point. Okay, so where is the position of the critical point? At the end of the line of liquid gas equilibrium curve. Okay, this one we call as critical point. For a better understanding, let's check out this video.
Let's take a closer look at the diagram and view the various parts on the molecular level. A magnified view within the solid region shows the regular array of tightly packed particles typical of a crystalline solid. Note that the particles in a solid are not fixed, but jiggle in place about their crystal sites. A magnified view of the liquid reveals a major difference between it and the solid. The particles are still in close contact, but their positions are much less restricted than in the solid, and they roll and tumble around one another. In stark contrast to the solid and liquid phases, a magnified view of the gas shows the particles far apart, except when they collide. At any point along the solid-liquid line, the phases are in equilibrium. Melting and freezing are occurring at the same rate. In other words, the same number of particles are moving from the solid to the liquid per unit time as are moving from the liquid to the solid. Similarly, at any point along the liquid-gas line, vaporizing and condensing are occurring at the same rate, which means that the number of particles moving from the liquid to the gas per unit time equals the number moving from the gas to the liquid. Finally, along the solid gas line, subliming and depositing are occurring at the same rate. That is, the same number of particles are moving from the solid to the gas per unit time as are moving from the gas to the solid. Two other features of the phase diagram are important. The first is that the liquid gas line ends at a point called the critical point, beyond which the distinction between a liquid and a gas disappears. Let's close in on this point and 2 points very close by to see what this means. At a nearby point in the gas region, the gas is under very high pressure, so the particles are reasonably close to each other. Thus, the density of the gas is relatively high. At a nearby point in the liquid region, the liquid is at a very high temperature, so the particles are beginning to separate from each other. Thus, the density of the liquid is relatively low. As these 2 points approach the critical point, the particles in the gas move even closer together and the density increases, while the particles in the liquid separate even more and the density decreases. At the critical point, the densities become equal and the phase separation between liquid and gas disappears. The second important feature occurs at the junction of the 3 phase boundary lines. At this point, called the triple point, the 3 phases are in equilibrium simultaneously.